So let's do some problems on these flow quantities. Okay, the basic problems on this. So the flow field is represented by u is equal to y cube by 3 plus 2x minus x square y, and the velocity component in the y direction is given in this way. So you have velocity components in x and y. So the question is, show that the flow field is irrotational okay, and the second is obtain the stream function phi. These are the two questions. Okay, so first we have to show whether the flow field is irrotational or not. For irrotational, your curl del cross v is 0. And how do you find out curl? Curl, the best way I would suggest is just write IGK dou by dou x, dou by dou y, dou by dou z, and put u, v, w. So in this case, I, j, k, dou by dou x, dou by dou y, dou by dou z, u is already given y cube by 3 plus 2x minus x square y, v is already given xy square minus 2y minus x cube by 3, k is 0. So if I happen to find out this, I will be dou by dou y of 0 and dou, so this is 0 minus dou by dou z, you don't have any z component here, so 0 minus j, dou by dou x of 0 is 0, dou by dou z of this cross, there is no z component, so 0, plus k, dou by dou x of this. Now dou by dou x of this is y square, don't have in the second term. The third term, it is x cube, differentiate with x, so it is 3x square by 3 minus dou by dou y of this. Dou by dou y of this, so let's write down this way. Dou by dou y of this will be 3y square by 3, and when you differentiate with y, the other term is x square. So this is what you get when you differentiate. Okay, so you have 0 0 plus k, this is y square minus x square minus y square plus x square, so this is in fact 0. So your curl of velocity vector is 0, so it's a case of irrotational flow. So a bit we have already shown. Now b bit is we need to get the stream function. Now stream function, by the definition, it is u is dou psi by dou y and v is minus dou psi by dou x. So what we do is u is already given, so let's take in this way y cube by 3 plus 2x minus x square y. So now we integrate with respect to x, integrate with respect to y, keeping x constant. Okay, so you will get psi as, when you integrate with respect to y, so this will be y power 4 by 12, y power 4 by 12, and then again if you integrate 2x, it is 2xy, this if you integrate n square y square by 2 plus some function of x plus constant. Why a function of x? Because just think about differentiating this back, you will get back function of x will be 0. Okay, so now I need to now get this function of x. So now if I differentiate this with respect to x and attach the minus sign, I can just compare with velocity vector v. So if I differentiate with respect to x, so dou psi by dou x would be 0, this will be 2y, this will be your differentiate with respect to x, so it will be 2xy square by 2 f dash x. So what I get is 2y minus xy square plus f dash x is dou psi by dou y. So minus dou psi by dou x would be, attach the minus sign, so minus 2y plus xy square minus f dash x. This has to be equal to v, and what is v? Xy square minus 2y minus x cube by 3. So comparing this, we get f dash x as x cube by 3. And so what is f of x? So f of x has to be x power 4. When you integrate, x power 4 by 12 is f of x. So now if I can just substitute back f of x here, I get a general expression of psi, which is y power 4 by 12 plus 2xy minus x square y square by 2. F of x is x power 4 by 12 plus some constant. So this is the stream function, x power 4 by 12 plus y power 4 by 12 plus 2xy minus x square. So this is the stream. So this is how you find out a stream function when velocity components are given. From each of the definitions you get psi, a stream function, and then either you can get psi. There are multiple ways of doing this. You get psi from this, and then equate, get that constant function, or you first find out psi from one function and then differentiate, so, and equate it to the velocity, the other velocity component. So this is one problem. So now check whether the following fields are irrotational. So that is another question. We need to check whether these two fields check for rotational flow. So u is cy, v is minus cy, and we have another question, u is minus ch by y, v is c log xy. So how do I check? For rotational, I'll always check the curl, and curl is ijk dou by dou x, dou by dou y, dou by dou z. This is ch minus cy, this is 0. So I would be dou by dou y of 0, dou by dou z of cross 0, it's not depending on x, minus j would be dou by dou x of 0, 0, so this is also 0, plus k dou by dou x of cy. You don't have any terms 0, dou by dou y of ch is 0, so it's 0. So the first field is irrotational. That is what we get for the first field. Now for the B part, let's do it in the same way. ijk dou by dou x. So the questions that come to the gate are mostly of this type. Check for compressible, check for, or the questions on the fluid acceleration. So I into dou by dou y of 0 is 0, dou by dou z you don't have depending on z, minus j dou by dou x of 0, 0, dou by dou z of ch by y 0, you don't have depending on z, k dou by dou x of log chy value, you have log xy is xy into internal derivative y minus dou by dou y of this, dou by dou y of this will be minus ch is constant. Now when you differentiate with y, it is plus by y square. Okay, so this is 0 plus k, this is c by x minus ch by y square. So this is not irrotational, this is not turning out to be 0, it's a case of rotational flow. So problems like this you can easily find out rotational and irrotational flow. Let's do another problem. For a 2D flow, phi is 3xy and the stream function is 3 by 2 y square minus z square. Determine the velocity components at points 1 comma 3 and 3 comma 3. Okay, so I can use either of the things. So let's use the phi for velocity, because the velocities are all defined in terms of each of these functions. So u is minus dou phi by dou x, v is minus dou phi by dou y. So u will be minus dou phi by dou x is minus 3y, and v is minus 3x. So at 1 comma 3 u will be minus 3 into 3 minus 9, and v will be minus 3 into x, which is 1 minus 3. So minus 3 minus 9 comma minus 3 are the velocity components at point 1 comma 3 at u comma v, and at point 3 comma 3 it will be minus 3, so minus 9 into minus 9 comma minus 9. So this is how you can find out the velocity at. So we have done 3 or 4 kinds of problems, where one kind is check the rotational and irrotational. So you have to just find out the curl of v by this determinant way. Other way is, given the stream function, you can find out the velocity. So that is what we have done in this problem. The other type will be find out the acceleration. So you have to just use those the acceleration equations. The other kind of problem is, given one phi and find out, you need to find the other function. So then what you have to do is, once the one of the function is given, let's say velocity potential is given, you need to first find out the velocity expressions for the velocity components u and v, just similar to what we did in the problem. And once you get u and v, now u and v you can express in terms of stream functions definition. U is dou psi by dou y, v is minus dou psi by dou x, and from there you will get two expressions for c. So you can just find out the constant. So we have done one problem related to that. So this is how, these are the kinds of problems that come from fluid kinematics in GATE. So better luck.